Okay, well, good day. My name is Berkenda. I'm the Director of Operations and Strategic Projects here at OmniAir Consortium. I see quite a few familiar names on the attendee screen, but for those of you who we have not met, OmniAir is a leading industry association promoting interoperability and certification for connected vehicles, ITS, and transportation payment systems. Our members include connected vehicle, ITS and road technology device manufacturers, ITS deployers, testing laboratories, and other stakeholders, all promoting the proliferation of certified interoperable devices. For nearly a decade, we have provided the opportunity for members to work collaboratively to develop and determine the requirements for national certification programs. Our members have the opportunity to shape the future of ITS and IoT technologies and to work with industry leaders and transportation professionals to accelerate their interoperability. Before we get started, I have just one housekeeping reminder. Questions are definitely encouraged. We will have time for Q&A with our entire panel near the end of the presentation. However, you may submit questions in the questions box as they come to mind. You don't have to wait until the end. With that, it is my great pleasure to introduce today's presenter, our Senior Manager of Technology Programs, Aaron Moore. Aaron, if you can go ahead and pop on your camera, the floor is yours.
Thanks, Berkenda. Thanks everybody for attending today. We'll go ahead and get started. 1 second, sorry guys. Okay, can everybody see the screen? That would probably help as well. Now, should be on the screen. Everybody should be able to see that. Yes. Thank you. So this is the webinar, Test Control Interface version 3. These are a few of our presenters today. We'll have 4 different companies shown on here. We also tried to get a few test labs. Both of the test labs are actually on holiday today, so they couldn't participate. So we will have Bill McKinley and Jerry Fitzpatrick from Keysight. We'll have Dirk Tiepelman from Spirent, Mustafa Qasim from Danlaw, as well as Abhishek Kumar. He should be giving us a 5-minute demo of the actual TCI message generator, and then we'll have Nick Hagemeyer. So just a few of the topics that we're going to go over today: the importance of TCIv3, the implementation learnings from all of our speakers, what exactly is TCI. We'll get to know the GitHub as far as modules, the new releases, and the projects. And then we should have some time for panelist questions as well as open floor questions. So just a few questions for the panelists as well as the viewers to keep in mind during the webinar. Why do you believe TCIv3 is important? What steps should we take to help our device manufacturers / test equipment vendors in implementing the new revisions of the TCI? How do you see TCIv3 being incorporated in our application testing? So those are 3 questions to keep in mind. So next, what exactly is TCI? So the test controller interface, or as we're calling it on this webinar, TCI, it is a message interface between a test system as well as a device under test. For purposes of this webinar, it will be called the DUT. You also see SUT and a few other things thrown out there from time to time, but we are calling it DUT for this webinar for conformance bench testing purposes. So TCI, it is designed to simulate valid and invalid protocol behaviors, as you will see later on in this webinar, and to actually analyze that reaction of the DUT. All commands used with TCI shall be sent via UDP or user datagram protocol. That is a typical internet protocol suite, and if if you're familiar with internet protocol suites, you should be somewhat you should know somewhat about the UDP protocol. The DUT will run the test control interface application, or as we call it on this webinar, the TCIA. To decode commands received and use the appropriate software interface to execute commands from the test system. So just a few examples of the message exchanges. We first have the test system sends response to the DUT and sends request to the DUT and receives a response. So as you can see there, the test system is actually sending that request and it's shooting back the appropriate response. So an example of this is the test system sends to the DUT that it needs to transmit a certain 1609.3 message type. That DUT then responds back to the test system and says, yes, I am transmitting. The second message exchange example, that is going to be test system sends requests and receives information from the DUT. So that test system actually sends to the DUT that it needs to know the DUT's hardware version, software version, so on and so forth. And then that DUT actually sends that information back to the test system. The third message type that's supported within TCI is the DUT sends the unsolicited indication to the test system. So you see here the test system sends the message to the DUT. Once that specific event occurs, it actually sends that indication back. So just indication examples that that could include result code, PSID, as well as repeat rate. And finally, we have the DUT sends an unsolicited exception to the test system. So as we see here, the DUT is only sending the exception back to the test system. Examples of that exception could be critical errors, incorrect parameters, or even radio interfaces unavailable for whatever reason. So just a few topics as far as a few items as far as the importance of TCI. It decreases the time spent, eases the amount of testing that is needed. There is a factor of ease of access of the TCIv3 for members. It is scalable and it is radio agnostic. So as far as decreasing time spent, TCIv3 implementation decreases the debug and testing times of devices. Just having that layer in between just makes it so much easier actually to test that device. This goes into the ease of testing, so it does give a standardized way to conformance test all layers of the device, whether that's the radio, 3GPP, as well as the 802 layer, or the upper layers. We have TCI commands for the 1609.3, 1609.2, as well as the BSM layer, or BSM transmissions, the J2945 and the 3161. Next up, we have ease of access. So it is accessible, like I said before, to all OmniAir members, and it's easy to implement comments and changes using our OmniAir Consortium GitHub. As far as scalability, I mean, TCIv3 has the scalability to not only test to current specifications, which I stated above in ease of testing, but it can also be implemented later on down the road for, say, application or security testing. Last but not least, it is radio agnostic, which you will see this many times during the presentation. TCIv3 is radio agnostic. It incorporates aspects of both DSRC devices as well as the current CV2X devices on the market. So V2 also had some ability to test CV2X, but it didn't have the full implementation of CV2X as far as the radio layer and the J3161. So this comes to our panelist speakers. First, we will have Bill McKinley and Jerry Fitzpatrick. Bill and Jerry, if you guys could turn on your microphones as well as your webcams. Thank you.
Okay, great. Thanks, Aaron. I hope everybody can hear me okay. It's nighttime over here. We're based in Scotland in the UK, so I apologize for the poor lighting. I just can't seem to get my lights working for these kind of things. Okay, so Jerry is our R&D lead for our CV2X and also DSRC solutions. I'm a strategic planner in Keysight. For those of you who don't know, Keysight Technologies, we're a test equipment supplier. We've been members of OmniAir for several years. We have both solutions for DSRC and ITSG5 for Europe, and also for cellular V2X. And Jerry's going to give an overview of our TCI implementation, but I thought I'd just give a quick overview to say from a test equipment supplier, having standardized test control interface is really an important aspect of making an efficient mechanism for testing different types of devices. You know, Aaron mentioned this radio agnostic. Obviously, we have different modems, different chipsets out there. And yes, each chipset can be controlled very custom specific to the chipset, but that's very timely. It takes a lot of time, a lot of support issues, gets very complicated very quickly. So a common way of testing devices is hugely important. Makes things more efficient, less costly for test labs to implement these tests, the certification. So it's really a win for the whole organization. So with that, I'll pass over to Jerry to just talk through some of the technical details of our implementation. So thanks, Jerry, over to you.
Hi everyone. The slide I'm showing here essentially is an overview of what a communications path with the, in this case, Keysight, but essentially any test equipment will use to execute the OmniAir test cases, and then specifically use TCI for that control mechanism. The blocks I'm showing here is some tech. Oh, I've lost the slide. The blocks showing in the center here, I think, Aaron, are you still presenting that? I'm just seeing some images.
Sorry about that. Yeah, I think something just popped up. Yep.
That's better, thank you. So the block in the center is some Keysight test equipment for handling the over-the-air RF interface and all the associated modem, etc., and the ITS stacks. However, the key point, well, that is somewhat agnostic to how TCI is used. That can be any test equipment. I guess it could also be another DUT. But let's not go into the detail of that. In this case, it's a Keysight test equipment. But what I want to speak about a little more is what I've highlighted in the green dashed box here. So this is the communication means that is used between what we're showing in the top left, which is essentially a test case engine. So this is something that has taken the specifications from OmniAir, configuring the DUT up to perhaps use a particular channel, a particular bandwidth, a particular power level. Specifically important for TCIv3, as Aaron mentioned, that's been an enhancement that wasn't in place for the PC5 link, and wasn't there for TCIv2, so certainly one of the improvements. So the test case engine essentially implements the test case, and part of that requires control and configuration of the DUT. That's what I'm showing in this green box here. Now that's a logical connection. Physically, in our case, it would be running typically over an Ethernet connection. I guess there's nothing to stop it running over Wi-Fi. It's just an IP UDP connection that runs over port 13001 by default in TCI. So in this case, what will happen is the test equipment will simply open a UDP port and then start sending commands to the DUT and expect responses for the specific setup, configuration, start, stop scenarios that are required for each of the test cases. So what we'll see in the next slide, not just yet, Aaron, but is basically an execution of that path between the test case engine, which is running in the test equipment, and the various steps of how we actually realize a test case using TCI. So, okay, next slide, please, Aaron. So one of the example test case I've taken is one of the ones that could not have been implemented rather with TCIv2 because it didn't have the capability of configuring and controlling the CV2X physical layer channel. So this is one of the the SEA 3161-1 based test cases looking to stimulate data from the DUT to make sure that it performs the correct encoding of the messages in terms of how the MAC layer works. This is sending either semi-persistent scheduling messages or event-based messages as specified in the SEA doc. So what I've pulled out here are 4 sections. The top one, step number 1, is to configure the DUT. So that is showing us on the top right-hand side here, the exchange between the test equipment, which seems to have gone off the top of the slide a little, which is the left-hand side, and exchange of messages to the DUT on the right-hand side. So the 2 messages we're required to send to configure the DUT is to set initial state, and from that, hopefully we get a success being sent back from the DUT, which then triggers essentially the configuration of the WSM information here. Now, what I've missed out intentionally here, and we can maybe touch on it later, is there is optionally a bunch of messages that can be used to configure the DUT in terms of the side-link configuration message. This is another new addition for TCIv3, which allows the ASM1 encoded UPair RRC message, lots of acronyms there, apologies, a bunch of hex essentially, that can be configured and loaded down to a modem, which tells it which channel to use, which EARSN, as it's called in cellular V2X, which bandwidth to use, and which selection of, say, resource blocks and various other physical layer parameters. Now, I've missed it off this particular test step because that would be probably done once at the beginning of the whole test regime. We can talk a little bit more of that later on. So specifically, this is the configuration and control of this one individual test case with the pre-configuration done prior to this. Next step is what I have highlighted in blue. Oh, sorry, same. Sorry, Aaron, still on this slide. Lots of detail. Yeah. So the blue part is another new message to set the flow configuration. This is again something specific to the PC5 setup, where it configures either semi-persistent, the kind of heartbeat messages being transmitted by the DUT, and also the emergency event-based messages, the hard braking event flows, etc. So that's a new message there, but still under configuration and required for this test case. Next part is the yellow part, where firstly, we request the SUTS availability. Now, this is key, particularly for cellular V2X, because before the DUT can actually send or receive data, it needs to be in a state where it has a GNSS lock and essentially its modem is good to go. Without a GNSS lock, the device cannot synchronize its physical channel, therefore it cannot either send or receive data. So we require to request the device's suitability or its status, essentially. SUT availability and status comes back with success, we're good to go. And then we use a message which actually existed in TCIv2, which was start WSM-TX. So start transmitting some payload. Typically a BSM, could be a WSM, sorry, it could be anything actually at the 3161 test case. Could be a WSA, doesn't really matter. It's some payload. The important part is the test case will start monitoring these SPS and event transmissions which have been configured. After some time, the test completes and we then send stop WSM-TX to the device. And then it should respond and we're essentially done. At that point, the TCI is complete for this test case. Okay, let's delve into just a little bit more detail here. So next slide, please, Aaron. So this is the same message exchange, but I know it's a little small, but hopefully you can see the kind of information that's actually being sent here. This set initial state basically means reset the stack to a known state. Next message down, PC5 set WSM-TX info, and the kind of things being sent there. You can see which radio to use, which antenna to use, the MAC transmission address, is this secure, unsecure, etc. And then the flow control, as we saw previously, the previous test was configuring semi-persistent scheduling on a particular priority, or PPPP, PROSE per packet priority, and the periodicity, etc. So that's jumping into the detail there. And finally, we ask the device to transmit, start WSM-TX with a big bunch of hex being requested to be transmitted by the DUT. I think in that particular case, that may be a BSM. Doesn't really matter for this particular test case because it is testing modem operation, which is somewhat agnostic to the ITS payload, BSM, WSA, whatever above there. Then finally, stop. Okay, we do have even finer detail of the exchange and the encodings of the message, which maybe Aaron can make available to the group once we're finished. I don't think there's much point in going into the ones and zeros and the ASM1 encoding of it there thereafter. Okay, next slide, please, Aaron. Okay, so we've been using TCIv3 with a few DUTs, specifically at probably previous two Plugfests, and we've been asked to share some of our observations. So we've got 4 or 5 bullet points here of what we've observed, typically of device manufacturers, implementations, and perhaps some issues associated with that. So number 1, GNSS is incredibly critical for PC5 synchronization. However, TCI also has a mechanism for essentially overriding the GNSS location of the DUT, and that's very useful for moving test cases where we want to stimulate the DUT being 10 kilometers away from where it started, the impact that has on security certificates, etc. However, we have seen some devices actually go into a bad state when we send that TCI message, because it essentially disables the real GPS input, and then they can no longer transmit or receive. So that's a bit of a gotcha for that case. If that happens, we have to stop the test case because all TX and RX stops. Second one, Aaron indicated that the device can send essentially indications of messages being received in his intro. Now, what we have seen is in some of the 1609.2 test cases where we intentionally send a bad security message, that message gets essentially discarded at the lowest layer in 1609.2. So it's the lowest application layer, essentially. And if TCI has been implemented in such a way that it only handles good messages, then what happens is there is no indication back to the test equipment to say a message has arrived, but it was bad, because the message has been essentially discarded too low in the stack. And that causes 1609.2 test cases to fail. So that's another one to look out for. Also, another one Aaron hinted at the beginning about SUT availability giving the status of readiness, essentially. Often we see the DUT will respond back with a positive availability. It's good to go, but does not yet have GNSS lock. Therefore, if we go too early, the DUT will miss messages sent from the test equipment or fail to transmit when requested to do so. So that SUT availability should be tied to the status of the device, not just the fact the thing is booted correctly. And that leads me on to the next one. Many devices do not physically reboot when requested to do so by the test equipment. Some of the test cases require the DUT to reboot to modify its MAC transmission, MAC source address for anonymity. Some do not reboot and therefore, again, fail that test case because the modem doesn't reboot and therefore often does not use a new MAC address. And finally, TCIv3 introduced this mechanism that I spoke at the first slide about the ability to send pre-configuration messages to the device. Now, that's using an XML format that not all chipsets currently support. So we've observed that is particularly implemented in one chipset, but not all. So that's maybe something where TCI has to slightly improve and be a little bit more generic. Okay, I think that's all from me at the moment, Aaron. Unless there's any questions for now, or should we take them later?
We'll probably take those later, Jerry. Thank you so much, and thank you, Bill. So we'll go ahead and move on to the next speaker. Thanks again, guys. The next speaker is from Spirent Communications. That is Dirk Tiepelman. Dirk, if you could put your microphone, unmute that, and then turn your webcam on. Thank you. Dirk, I believe your audio is off.
I have two buttons to press to unmute myself, so sorry for this. So thanks, Jerry and Bill, for this introduction. So it was already kind of showing a good overview about TCI in itself, the structure and so on. So my name is Dirk Tepelmann. I'm from Spirent, and I'm working for the conformance test since the beginning here for OmniAir test specifications and even before. So it's I've started in 2016 to support this ones, having supported TCIv3, V2, and now V3. And I'm also active since more than 10 years for the European stacks and as well for stacks in China, for example. So let's come to my slides. Some general aspects of TCI, which I always hear. It's something that do I need to implement the TCI application on my device, and would that have been some impact? So in general, TCI itself does not define where the TCI application might run. So it could be integrated directly on the device, so running on the same software stack, but it must not. So if you do have any other kind of interface, higher layer, upper layer interfaces of the stack itself, or some proprietary interfaces to your device, you could also have the TCI application running outside of the stack, or even outside of the device. So this is something which can also be kept in mind to have this possibility to have TCI not integrated directly on the device, but maybe outside of the device itself. Another question which is always arising, it's regarding ASN1. Why do we have ASN1 here for TCI protocol? So in fact, for the ITS V2X stacks, you are using already protocol definitions in ASN1. So it's for .2, for example, you're using encoding rules for CUR, or the UPair for CA J2735. And now with TCI, you have just another encoding rule. I just put that in marks because some of you may have some own opinion about that. So this new encoding rule, it's the OER, the octet encoding rules. And I just wanted to provide here also this little hint that if you're not that familiar with the different encoding rules, there's also a website which is providing a nice little service of putting your ASN1 definitions to this website, compiling this ASN1 definitions, and encoding values defined in ASN1 value notation, or decode already encoded ASN1 definitions. And this is can be found here on this website, https asn1.io, ASN1 playground.
Dirk, I don't think it's free anymore.
I used it yesterday and today, so this is still free. It might be that you will not have the full flavor which is supported by the tooling in the background. So this playground itself, it's coming from OSS Nocalva, which is one of the main ASN1 tool vendors. And for this TCI handling here, I've just tested that this is still supporting all the stuff. So it's no need to register actually here. So
one of our
this,
engineers, so I don't know if it's true.
say again, please. Okay. Then TCI in the context of CV2X or PC5. So if you are familiar already with TCIv3, which was dedicated for DSRC, you will also see that now with the TCI version 3, you do have this similarity between the DSRC and the PC5. In PC5, you will just have some DSRC specific things like channels, data rates, and so on absent in the definitions. And you will have two different frames in the 1609.3 frame instead of only one, which was before just dedicated to DSRC. Now you will have one frame for DSRC and one for PC5, but still both are kind of similar. And some other commands which are new, mostly for the radio configuration. So you will see set UI config or send UI config XML. So this two commands do allow you to set radio specific configurations, so radio parameters. For device vendors, you can choose what it's fitting best to you. So either set UI config or set UI config XML. If you do have a chipset which is already having support for an XML based stuff, which it's V2X XML, test equipment should actually support both of these devices. And another one, which we have seen already in the slides before, is the set flow config, where you will set the flow config information, what was defined before. So this is a short addition to what we have seen already to all the sequences and explanations in the slides before.
Thanks, Dirk. Thanks again. So we will take it over, and next we do have Mustafa Kasim, as well as Abhishek Kumar. So Mustafa has a few slides, and I think Abhishek has a quick demo of the TCI message generator. So Mustafa, Abhishek, if you guys could unmute yourselves and turn your webcam on, that would be greatly appreciated. Thank you. Thanks, Abhishek.
Hello.
Mustafa.
Now I am okay. All right. I can't seem to be able to unmute myself for a while. Okay. My name is Mustafa Kasim. I'm the technical lead engineer at Danlaw, which manufacture RSUs and OBUs. Sorry, I don't have video because my laptop is on a docking station, but Abhishek will present for the two of us. So Abhishek is also one of our engineers, and he has designed and implemented the TCI message generator for version 3. We had TCI message generator for version 1 and 2 before, and he was in charge of the porting of version 3 to a Windows application. Next slide, please. Okay, so in order for you to be able to implement TCI3, you need an ACN1 compiler. Why was TCI written in ACN.1? It's very simple, because no matter what kind of processor, no matter what kind of operating system you use, whether it's the processor is 8-bit, 16-bit, 32-bit, little endian, big endian, if you implement or use the correct rules, devices, completely different devices can talk to each other with no problem. Okay, so what's an ASN1 compiler? It basically translate the text-based ASN.1 code to your programming language, whether it's C, C++, Java, Python, and I am guessing most of the people here, since are using embedded system for devices, it will be either C or C++, but I could be wrong. So when you compile the, when you use the compiler to compile the ASN.1 code, it will basically give you a skeleton code, you know, like the function name and, you know, the arguments, and that's it. You are responsible for providing the meat of the code itself that will perform the intent of the message that you receive. Okay. If you have done SNMP before, it's very it's the same thing. An SNMP compiler, MIP compiler will give you skeleton code that you'll have to fix your, you know, you'll have to add a lot of code to it yourself. It gives you very little. Okay. So the available compilers are for, you know, the major languages: C, C++, C#, Java, and Python. I'm not aware. Maybe there is one for JavaScript as well, but I'm not sure. The next point is we try to find an open source CASN.1 compiler, but we couldn't find one. There are a couple, but the first one I tried to use, that VLM/ASM.1C, but it wasn't able to handle the structure of the TCI as it is. If you give it everything in just one file, it might work, but it just couldn't handle some of the intricate structures in TCI3. And the last one here, there is another one. I just found it on the web, but I have never tried it. I have never used it. So what I'm telling you now is basically, if you have already done something for TCI, there's nothing new here. You already know everything. So this is basically for the people who are new to TCI. Next slide, please. Okay, so ITU has a web page that shows you all the available AS1 tools. Okay, and the link is on the first bullet. And I'm listing here, Dirk mentioned before ASS Nucalva, which we used for, we actually used their C# compiler for our DSRC test certification. And we also used it for our TCI message generator, okay? And there is Objective Systems and Marvin. All of these companies will offer you a month trial, but after that you have to pay up. Okay, OSS Nucalva has a very nice GUI development called AS1 Studio. Something similar like Visual Studio, I mean to a smaller extent, not as the Visual Studio, but you know, something similar to that, where you could specify the AS1 source code, and then it you set the configuration to compile it, and then it will generate the code for you, whether you're using C, C++, or C#. And again, yeah, you know, you'll have to do most of the work. So if you have used TCI version 2 before, you will find version 3 easy. The only thing that it was added is the PC5 stuff, obviously, because before we did not have cellular when we started at TCI. TCI uses OER encoding, which is a byte oriented. Actually, you will be able to decode it yourself if you are patient, because it's byte oriented. It's time consuming, but it's different from the other encoding that that uses bit oriented. And I don't know if I'm correct in saying BAR encoded is J2735. Sorry, I haven't done that in a few years, so my memory probably doesn't serve me. And that's bit. I couldn't add any more than what Keysight and Spirent added. They have done a fantastic job explaining how the TCI messages are exchanged and all the requirement for message exchange. And so that's it for me. I'm gonna pass the baton to Abhishek to show you the TCI message generator 3. If you have used TCI message generator 1 and 2, it's very similar.
Thanks, Mustafa. So I will change presentation rights right now to Abhishek. Actually, I guess they've already got that. Thanks, Abhishek. Take it away.
Hi. Hello, everyone. I hope you all can see my screen. So I'll be giving a short demonstration of how the TCI version 3 simulator or the message generator can be used to basically validate how the implementation of TCI on devices. It's why we kind of implemented this in the first place. So for those who don't have any experience with version 2. Version 2 only had DSRC related message exchange, so which remains intact in version 3 as well. So like the SUT control, where you can request for SUT availability, it'll basically show you what was sent out, and if there was a response with success, the device responded with success, you'll see that. So this is 802 stuff, which remains the same as I said earlier. What has now been added is the PC5.3 layer. So here, if we send out, I have a device connected which does respond to the failure as of now, but you can send out messages. One of them being as mentioned earlier, the modem parameters, that if you have an XML file, you can send the same using load the XML file here. I can show you that it sends out the XML file in batches of 1500 byte chunks. If you want to load them individually, you can do that in the configuration tab, which is part of the TCI definition itself. Same goes for WSM transmit. Individual parameters will need to be entered if you want. If security is being used, as in certificates are loaded, you can use the same here. Define each parameter of a transmit message, loaded using the set command, start transmission, stop transmission. So all those things can be done using this PC5 tab here. Apart from that, we also have the WSM receive tab, which is basically the same thing, defining what the device should receive, what it is what you're commanding the device to receive. When the device does receive, you will receive the indications in this information window here. If it's a WSA, the WSA will be passed and individual parameters loaded up here. As of now, unfortunately, I will not be able to show you that because I don't have a second device here, but in the event it was available, WSA would be parsed, shown in this tab. Same goes for the BSMs. All other devices, you'll see the hex bytes that were received by the device sending back information as an indication. So there's also a WSA tabs for transmission reception, Unfortunately, I have not yet implemented this as of today, but it will be available in the future. Those are basically some of the choices that we have. There's also the 3161, which is basically similar to 2945. Individual parameters of a BSM can be configured. Yeah, please go ahead.
You too. Continue.
Oh, right. So yeah, that's basically it for individual parameters of the BSM. If you want to receive, transmit, you'll have to set the parameters accordingly. Core parameters of the BSM along with other part 2 related information of the BSM can be set and used to transmit, receive. This basically is meant to check implementation of TCI on the device if it matches your expectations or not. That's kind of what I had here. Yeah. So as I said, yeah, that's kind of all I have here. If any questions, I can take them.
Thanks, Abhishek. We'll actually have the open floor at the end, so if there's any questions, we will take care of those at the end, if that's okay.
Sure, no problem.
Okay, Burkinda, can you give me presentation rights again? Thanks again, Abhishek, for the demonstration.
No problem. Thank you.
Let's see. Make sure. Okay, stop sharing. 1 second, guys, sorry. Okay, can everybody see that?
Yes, sir.
Okay, great. Thank you. We'll go to the current slide. Okay, so thank you, Mustafa. Thank you, Abhishek. Last but not least, we do have Nick Hagemeyer from DriveOhio. Nick, if you could unmute your mic as well as turn your webcam on. Thank you.
Sure thing. Thanks, Aaron. So we've heard a lot about what TCI does and the configuration tools and things of that nature. Why is this? Aaron asked me why is this important to IOs. So I'll just provide a few little insights here onto why IOs feel like this could be an important step for now and for the future. So right now it's incorporating the TCI version 3. It's incorporating CV2X. Future developments could incorporate application simulation. As we talk about applications, it's very important to IOs to be able to visualize and see some of the results from some of maybe the TCI version 3 is incorporated into a test station that simulates the combination of a V2I hub in combination with the RSU. So we're able to showcase the application messages that are generated from the test station, and then see the results from the OBU as it's connected to the interfaces to the test station. So right now that ability is not there. I think that'd be a very good tool for in the future to really be able to visualize some of the alerts that are driven by some of the messages that are sent during some of those application tests. And then that way it's not just software based or conceptual. We're using actual devices and being able to showcase and driving into the second second topic of interoperability. So I can send one message out with one device, have that device receive it, send a response back, and then switch out another device and duplicate the efforts and see similar responses. What does that do for an IOO? On our time, it lessens the deployment time, so we don't have to necessarily come up with generalized specs for everything. We can just specify that it has to be OmniAir certified. It has to be an OmniAir certified device for a specific release of specifications and tests. It lessens the integration efforts, so we don't have to necessarily pay for integrator to come in and spend a lot of time and spend a lot of their resources making the system work. It's already set up to work. It's set up to be seamless. There may be some integration that needs to be done just based off general config, but we don't need to really get down into the software and firmware version level of the devices. And then based off of that, it also lessens the funding needs. So when we don't have so much time involved, we don't have so much efforts involved, now we're able to free up additional funds to perform more deployments. And then that leads into the deployment. So what is it going to take for IO acceptance? And we really have like a chicken before the egg, maybe a combination of chicken with a lot of chickens before a couple eggs. Right now, the IO perspective is, why should we deploy this stuff, or why should we deploy this technology when there's nobody to interact with it? So the IOs aren't there to receive the messages within the vehicles, and so we don't need to broadcast the messages. And the IOs are sitting back saying, well, there's nowhere for us to interact, so why should we deploy the technology in our vehicles? The same thing goes for, why should we deploy like TCI version 3 if nobody's going to certify their devices for OmniAir, or nobody's going to require OmniAir certification? And I think that all goes towards just general awareness of what the TCI implementation does, what OmniAir does, and then what are the benefits when we have a TCI version 3 deployment or implementation. What does that do for OmniAir, and then how can OmniAir share those lessons and share and increase the capability for ease of deployment to the IOs? So that'll be coming up in some of my next messaging to some of my IO counterparts. Really looking at what can we do from an IO standpoint as far as applications that may not revolve around OEM deployments. So what can we do as IOs for our own fleets, for our own emergency fleets, government fleets that we can control, and what kind of benefits can we drive directly from there? And then, I'm already hearing more and more talk about IOO acceptance and incorporation of OmniAir certification into their specifications. So that's the added benefit. I just feel like TCI version 3 is going to really accelerate, as we further develop and further integrate applications and other things. It's really going to accelerate the OmniAir certification levels, and you're going to see more of contract language coming out, really referencing what some of these OmniAir future releases may be. And I'll turn it back over to you, Aaron.
Thanks, Nick. Make sure my webcam's on. Okay, I just wanted to thank Nick again and thank all of the other panelist speakers. So next we will go into how to gain the access and other aspects of the actual GitHub itself. So I've heard a lot of questions. How do you exactly gain access to the TCIv3 GitHub? So to do that, you actually have to email me. So TCIv3 is for OmniAir members only. At this time, members can email amore@omniair.org, and then we can send an invite out to you to gain access. So just an example of that invite is in the bottom right-hand corner. You can see the GitHub, the invite. Yeah, so you just have to do view invitation, and then you'll accept it, and you should automatically gain access to that. So where is it actually located? The link to the actual GitHub is here. We can also send that out to you as well if you're having a hard time trying to find that. As stated before, however, if you do not have access, it will show that OmniAir has no public repositories, and therefore you will not be able to see the code or the rest of the GitHub. Another question that I get rather frequently, why doesn't my link work after a week? Or why doesn't it work after 2 weeks, or so on and so forth? So if you actually look down here at the invitation itself, the invitations do expire in 7 days. So if you don't accept it within that 7 days, you're going to have to send another request out. So that's just a few things on how to actually gain access to our GitHub. Like I said before, if there are any other questions or concerns, you can reach out to me at that email. I'll be able to send something back to you as soon as possible. So this is our actual GitHub. I've spent some time working on that, just updating it, getting everything together. As you can see here, there's the code, issues, pull requests, actions, projects, so on and so forth. For most of you guys that actually want to gain access to this, it's only really the code that you'll actually need to look at. It is in the main branch. There are 2 branches. I think there's another branch to actually do any of the changes. And that tag is actually, if you look to the right-hand corner, there's a release, but we'll go into that later. That tag is actually that release one. So as you can see on here too, the README file on the GitHub homepage, it's actually at the bottom of the screen. So that is the actual README file that's attached to inside the GitHub. Next, so getting to know our GitHub, we kind of looked at this before in the last slide, but I have separated it into a few sections. The first section is ASN.1 or ASN1 as it is on the GitHub itself. So this is the actual ASN.1 code for TCI version 3. We'll go into those modules a little bit more later on. We have a PC5 section. So that's actually a radio configuration information. That includes the latest V2X XML configuration file for your device for the radio settings. There's various support documentation as well on this GitHub. We'll go over that later on too. We have a section, but as far as that's concerned, we really have the TCI mapping document. There's the V3 document, the V2 document, and then I believe there's a V3 outline document. And last but not least, we do have the README file, which is the copyright and contact information. And if you see above, like I said before, it's actually down in the main page of our GitHub. So next, we'll go dive down a little bit deeper into the supporting documentation. So there's 4 different types of supporting documentation we have on the GitHub right now. These will be updated hopefully within the next few months, and we'll have a new revision out of these. So the first document is actually the OmniAir test case TCI mapping document. It's a really helpful document. It actually maps which TCI commands are used within certain test cases. The next document we have here is the test controller specification 2021-1007. That's the Rev 3, so that's the actual help document for TCIv3. Note that it's not an actual implementation document. We really don't have one of those, but it is an outline document for the different modules, as well as any other relevant information that's needed to really implement the TCI v3. Next, we have the test controller specification v2. So this is the TCI version 2. It is the previous version of TCI. It's not compatible with v3 as v3 is not backwards compatible, and the document is obsolete and is for just reference purposes only. Last but not least, we do have the test controller specification v3 outline. So this document was actually created before the new revision of the TCI document. It kind of gives an overview of what we're doing in TCI v3. As well, it sets up a list of priorities, say P1, P2, and P3. Those items include updating per specific, I guess, testing requirements, say application testing later on, or security testing later on. So next, it looks like we've got a mess up on there. Comparison of TCI v2 to TCI v3. So I'll go ahead and do this. TCI v2, there's a minimum implementation for CV2X devices on TCI v2. You can test TCI v2 on, you can test devices running TCI v2 for CV2X. However, you're not going to be able to test the 3161, the 6209.3 for PC5, or so on and so forth. Next, TCI v2 does not support AT commands for CV2X PHY testing. So the AT command wrapper is actually, I believe, in 1609.3 PC5 as well as the common types for TCI v3. That's actually not located in v2. Last, TCI v2 only supports the 802.11 PHY layer testing. So as far as both TCI v2 and v3 are concerned, they both are DSRC compatible. They both send UDP via IPv4 protocol, and they are also a standardized test interface between the DUT as well as the test equipment. So TCIv3 does support both the 802.11 for your DSRC testing as well as the PHY CV2X radio layer. It fully supports CV2X and DSRC, as we've stated before. Also supports the radio configuration commands, whether that be AT or other commands per chipset manufacturer's specification, and it is not backwards compatible with version 2. So now we'll go into the ASN.1 modules. This is another aspect on our GitHub. So once you actually click on the ASN.1, it will take you to this screen. We'll go over the first few in this slide, and then we'll touch the others in the next slide. So as Mustafa and a few of the others have stated before, various ASN.1 modules, various things are incorporated from V2. However, there is no backwards compatibility from V2 or V3 to V2. So if you're really wanting to get that full aspect of CV2X testing in, you really need to go to V3. So these are just a few of the files. The create_TCI all.bat. That is a batch file which will create a single ASN.1 file from the ASN files in the TCI project folder. And the 609.3 subfolder. The .3 set WSM txinfo.txt is an example of how to call the .3 set WSM txinfo command. I don't think any that has changed from the last revision. Then you have your actual commands per section. You have the 609.3 DSRC. Which is grouped for the TCI commands for, the 609.3 TCI commands for DSRC. 609.3 PC5 is the new updated module to support 609.3 TCI commands for CV2X. .4 is only DSRC. We have not included that into CV2X as of yet. J2945, that is the BSM message set commands for DSRC. The 3161, as a few people have touched on it before, that's the BSM commands for the 3161 for CV2X. And we have kept the TCI 802.11 as well. So you still have those commands for DSRC for the PHY layer still. Last but not least on this slide, we have various radio information. So that's going to be radio number, antenna, time slot, repeat rate, so on and so forth. It also includes some of the exception information. So if you want to learn more about the exceptions, it is located in TCI common types. Next slide. So these are the final modules that we have in the current GitHub. So we do have the TCI dispatcher.asn. That's just an outline of an actual TCI message, as well as items such as frame choice. TCI event handling.asn, those are actually device flags. So any event flags that are set within, I think it's the J2945 as well as the 3161, any of the security flags that are set, and so on. The next module, we have TCI project.a1sproj. From what I've seen, that is an ASN Studio project file. I personally don't have that much experience with this module, so one of the guys online probably know a little bit better about that. TCI set control. So since we're using DUT in this webinar, this is DUT control, which is sending a device a request, say, to restart, shut down, to request certain information, and so on and so forth. TCI indications, another one of those message transactions that we saw, I guess, at the beginning. So this kind of explains the indication messages, whether that's success, inconsistent parameters. I think we had a few more as well. TCI IP, so these are the IP related TCI commands. I know there's a lot of talk for trying to figure out the whole IP, I guess, IP connection in the CV2X world. Since I think we stated before that TCIv3 is scalable, we can actually scale that for the TCIP to relate towards CV2X as well later on whenever it's needed. Next, another important module, we have the TCI proxy CV2X.asn. So those are proxy, kind of like a proxy setup for CV2X and TCIv3. The proxies are used on a majority of the test equipment. It's just a way for a device to actually transmit to another device, to receive from the device that's being tested, so on and so forth. The last two modules we have the TCI response info.asn, which is just response information from the DUT, whether that's packet count, DUT information, I think hardware revision, software revision. And lastly, we have the TCI WSM. That's going to be parameters for numerous types of messages. I think the messages that are on there currently, WSAs, BSMs, MAPs, SPATs, and TIMs. So, right before Christmas last year, I actually put a little time and effort into getting this version control figured out in the GitHub. So now we do have a TCI release 1, which is R1.0.0 in the actual GitHub. So this sets it up, makes it a little bit easier to download, as well as it just makes it a little bit easier on here to locate which version or which revision we're actually on, so on and so forth. So whenever we come out with a new revision, it's still going to be TCI version 3, but say it'll be release 2, release 3, so on and so forth. So this is available by clicking on the tag here. Yeah, so it's there. And then once you click on that tag, you can click on the source code zip to download the release. That's there as well. Animations didn't work too well for that one. But yeah, like I said before, if you have any other questions, concerns, if you can't actually look at this release or download that, please reach out to myself and we'll get that fixed. The last new, I guess, thing we've added to the actual GitHub itself, I did create a project. So this project's just an easier way to keep track of any improvements, changes that are needed for the GitHub itself. So we do have a to-do column, as you can see here. We have items that are in progress, what we're working on right now. We also have done, which the only thing we have done right now is create the release for TCI code. That was the release 1. And continuous, I just added a column, called it continuous, and that's everything we're going to be do to update the GitHub continuously. So now we'll move on to panelist discussions and questions. Panelists, if I could get you guys to unmute your mics as well as turn your webcams on. I will ask questions. I think we have 3 questions that were at the start. And then we'll go in the order of by which you spoke, I guess, during the webinar. And then we will have an open floor. So if you guys could just turn your webcams on real quick. Thanks, Jerry. Thanks, Bill. Dirk Abhishek. Nick, I'm assuming Mustafa's there as well. So the order we'll go in, yes. Thanks, Mustafa. So we'll go Keysight speaking first, Spirent speaking second, Danlaw third, and then Nick from DriveOhio will be fourth for each question. So why do you guys believe TCIv3 is important? Jerry, Bill, I'll let you take it away.
Well, maybe I can take the easy one. I think it was mentioned on by almost everybody. I think I don't know. The benefits are fairly straightforward as far as I can tell. You know, a standardized way of interfacing to devices just makes life simpler. We rely, less on specific commands for different devices. We can then have common parameters that we all agree on and recognize for troubleshooting purposes. Test labs are able to implement these tests much more efficiently, and the support is just easier. So I think it's really straightforward, and I guess from a global perspective, TCIv3 is, as you said, Darren, under the ownership of OmniAir. Other regions are going to have to look at this as well. I mean, a standard test control interface And I think a discussion might be a good thing to have in other regions if TCIv3 is made made available to other regions. Or I think other regions are maybe going to have to reinvent the wheel. So it's something that I think OmniAir directors may have a discussion about. Perhaps something to do with 5GA and make it global. But anyway, I think the benefits are very clear. I hope that's everybody can agree on.
Thanks, Bill.
Yep.
Jerry, do you have anything to add?
I think Bill's pretty much covered it. Certainly from our, if I can say, selfish test equipment perspective, it means we don't have to. We have a standardized interface to DUTs. We don't have to specialize. It gives us consistent behavior, all that good stuff. I think we've spoken at it at length. Yeah.
Thanks, Jerry. Dirk, you're up next.
Yes, so as Jerry and Bill were already saying, it's always a good idea to have a standardized interface, and here we are having a standardized interface which is supporting the testing and the certification. And when I'm saying the testing, then we should also have the aspect in mind that we are also talking about test automation. So with such a test control interface, you are able to test or to run all the tests without having manual interactions. You will just be able to put that in your, let's say, DevOps pipeline. Yeah, so you could run this stuff also during the night or whenever you have a change in your implementation. You can test it quite easily because it is just running automatically for you. You don't have to be in front of the test system and the device to have a look to the test system, what is required, and go to the device to manually set up the right things. All this is done via this standardized test control interface. And as we have already said, this is something which does also applies to other areas where the same kind of concept is used. And here with OmniAir's TCIv3, we do offer already a standardized test interface, which also does cover anything related to CV2X. So this might be also of interest for other standardization bodies which do have also a kind of test control interface or upper tester, however it was called.
Thanks, Dirk. So next we'll have a device perspective from Mustafa as well as Abhishek, if they would like to speak.
Well, from our point of view, it basically we know what the test equipment manufacturer will be testing, so we don't have any surprises. Like they said, Jerry and Bill, and Dirk as well, there is a common interface that everybody agrees to, so no surprises, basically.
Thanks, Mustafa. Abhishek, is there anything you'd like to add?
No, I guess basically the same thing. That way, the devices won't have to, I mean, specifically implement something new, so that the test equipment will require. So basically, yeah, standardizes communication between the equipment and the device, which is makes things easier, life easier for both sides, I guess. Yeah.
Thank you, Abhishek. And last but not least, Nick, as far as an IO perspective.
Sure. I think it's just, similar to what everybody else has said, from especially keying in on a couple points that Dirk has said, with the automation perspective, not only being able to run tests overnight or automatically, scheduled tests, but being able to run the same test on every device the same way. And it really gets to the point of interoperability at that standpoint. You're not having to modify the device to encode or code within the test system to communicate with the device. Everything's run the same way and is expected to run with the same operational functionality.
Thank you, sir. So now we'll go to the second question. What steps should we take to help our device manufacturers, test equipment vendors implementing the new revisions to TCI? So we'll go through again. If you guys can maybe, I know we're kind of pushing time now, so if you guys could maybe limit your response maybe to around 2 minutes per, that would be greatly appreciated. Keysight up first. Bill, Jerry.
Actually, Jerry, answer this one. Yep.
Well, first thing I'd like to do is actually thank Danlaw for providing this new tool. It's proved very useful for TCIv3. So the Danlaw TCIv3 encoder will give both test equipment, but most specifically DUT manufacturers, the ability to stimulate TCI in a well-defined and controllable environment. So I think that's something that's been a little missing. Maybe we could go all the way to actually have a standard implementation or a reference implementation, but then that gets down into the how is the SM1 used? Is it embedded C? Is it what C++? It all gets a bit of a mess there. But having the ability to actually have independent generation and reception, decoding of these messages, I think will certainly be a big starter for 10, as we say, for to get implementations moving on this. Bill, anything to add?
No, I think a Wireshark dissector may be another thing that we've discussed in the past as well. Perhaps it would be a good tool to have. But no, I agree that the Danlaw, that little utility has proven very, very helpful. So yeah, concur.
Yeah, the dissector is a big plus, mostly because it gives us live independent decodes. Obviously, we cannot use the Danlaw tool readily for that when we're at Plugfest, etc. So when we get to the inevitable arguments about implementation at Plugfest, it's nice to have independent arbitration. So that would be good.
Thanks, Jerry. Thanks, Bill. Dirk, do you have anything to add as far as test equipment perspective?
What I would like to point out is that at the OmniAir GitHub, there you will also find test sequences which are showing you the expected TCI commands per test case or per test step in instruction. And this will also show you a kind of good overview what would be expected from your device in running any test sequence. So I don't know, Aaron, if you have this right by hand to also show this, but as far as I know, this is also provided on the GitHub for the TCI.
Yes, I believe we have specifically, Dirk, are you talking about the TCI mapping document, or are you talking about examples in the ASN?
I think there's also this, this mapping document, it's one, and there were also this test sequences which have illustrated the use of TCI.
Yeah, it was a function of TCI message generator 1 that we recorded it records all the communication between the computer where you're sending TCI messages and the DUT, and it keeps a record of all the message exchanged in a text file. That was done. I don't know if Abhishek implemented it for version 3, but that was available in version 1.
Yeah, I can easily make it available in version 3 as well.
Yeah, okay. It will be beneficial.
Yes, definitely.
Thanks, guys. Dirk, do you have anything else?
No, I think that's it. I mean, we have collected here all this stuff as we have seen this that maybe Wireshark dissector would be something which could add in the future. Then this TCI version 3 examples generated out of the tool. And with this test sequences where it's shown what is expected per test and also this mapping document, I think we have a very good support here also from OmniAir side.
Thanks, Dirk. So then we'll step into Danlaw. Mustafa, Abhishek, do you guys have anything to add?
I have nothing to add. I think we are flattered that the TCI message generator is so useful and important.
Abhishek, anything else?
Yeah, I guess people have covered everything. So we are always welcoming any improvements that you guys can suggest. We can definitely put it in. No doubt. Yep.
And Nick, as far as an IO perspective?
I guess, nothing really technical. I guess what you showed on the GitHub site, the project site, with all of the sort of outlining the roadmap for TCI, I think that's very helpful, and just continuing to provide and update that information so that it gives a good set of expectations for what's next for the group.
Thanks, Nick. Okay, guys, so we're at our last question before open floor. A little bit harder, I guess, but how do you see TCIv3 being incorporated in our application testing? We have had a few members, I think, at the last Plugfest come up to Randy and asked him how to actually use this TCIv3 in our benchtop application testing. So Keysight, I will start with you guys and then go on from there. Thank you, gentlemen.
Yeah, well, it is a little bit more difficult, I think, to find. But I think what Jerry and I were discussing this just before we came on, and we're not OEMs or manufacturers of vehicles, but from a sensor fusion standpoint, we believe that some of the devices don't operate unless a lot of the sensors are stimulated. In other words, it's not just the CV2X, it could be braking, it could be LiDAR, and so if there was a way that TCIv3 could send messages to, I don't know, load up some of the registers on the sensor, so the sensors are in a sense in play, that allows the CV2X to do its thing. And so perhaps there may be something, but I don't know if Jerry, if you've thought of anything else in the interim.
I think there is some capability already there with some of the 2945 control about setting brakes, setting exterior lights, or anything really, but mostly the asynchronous events I think would be good, because this has popped up at the last Plugfest that, as you say, sensor fusion, it's not just GNSS that's required to stimulate full applications. So TCI as it stands today can do some of that. I certainly think there's scope where we can go beyond there, and I think stimulate rather full application levels.
Thanks, Keysight. Dirk, would you like to add anything?
I think before we are going into much details in incorporating application testing and TCIv3, we need to collect the requirements which are actually giving for all the use cases we want to handle with the application testing. So we could, for example, enable and disable certain use cases. We could provide any kind of parameterization if necessary for testing, so that you say, okay, you want to have this and this event in a distance of X instead of Y. So we would need to check here how useful it is also in regards to parameterization of applications, so that the device will handle as the test system or the test purpose actually requires to get this kind of events when dealing with this application testing.
Thanks, Dirk. Mustafa, Abhishek.
I think we should start with just a couple of applications. Testing conformance to the standards is easy. It's static. Application will require you to be moving and include not only if you're testing OBU, you're only testing an OBU. If you're testing an RSU, you're only testing an RSU. But in this case, you will be having to test both of them, and it requires movement. So maybe we should start with only a couple of simple applications and then to kind of debug, and then add to this. Abhishek?
Yeah, I guess especially when it comes to V2V applications, as I guess it was mentioned before, that you need some way to simulate how the sensors act, right? So if without sensors, devices will not respond to messages. For example, heartbreaking as it has already been mentioned before. So those will also need to be incorporated in TCI somehow, which otherwise I guess that would help in definitely during application testing as well. So that is something that probably we should look into as well, and then start with a as start one application at a time, and then we can build on that. Definitely.
Thanks, Abhishek. Thanks, Mustafa. And finally, we have Nick.
So when I think of application testing, I appreciate all of the insight into sensing, things like that, incorporating additional sensing values and sensor values into the system. But I also think that we need to look at what is the output generated from an OBU. How can we incorporate that into? How can we incorporate an alert into the test system, receiving that alert information, so that we can record it and not have to have somebody there on site looking at a HMI or some other visual representation of what the OBU's outputting to the motorist.
Yeah.
We can have that set up into the test system so that it automatically generates that, and we can go back and look at it. So those tests can be run more autonomously.
Yes,
Okay.
exactly. So for this kind of events which are raised then by the OBU, we would need some kind of standardized indication back to the test system to be able to check the pass criteria, so that the device under test actually is enabling the right event at the right time. It's also something which needs to be incorporated, the time to event or the distance to the event, etc. So this would also be something which needs to be considered.
Yeah, and I feel like a lot of that could be set up in each test case individually based off of, if this then that criteria. For certain tests, if you're traveling at a certain speed, you may want to be notified at a farther distance away from the message source or the location than if you're traveling at a lower speed and things of that nature. I think all based off of, it's really all application independent. And, looking at each one of those and kind of driving, and maybe it's IDIS codes. I don't know. Maybe it's, just broadcasting out the IDIS code that you would alert based off of the message that you're receiving, at least for those TIM messages that, for those applications involving TIM messages that we would use. Maybe it's just outputting the IDIS code to the test system at the time when the alert would be created.
Okay. Thanks, gentlemen. We'll now go into open floor. I believe Burkinda has a few open floor questions.
I was on mute. Can you guys hear me?
Yes,
Yeah.
Yes, we can.
Okay, so there's a couple. Looks like the first one is going back to the GitHub slides. It says, I'm seeing last significant GitHub commits are 13 months old. Please confirm, only a copyright notice added in the last 1 year.
Yes, so that was the original revision. That revision 1, we haven't had that many updates as far as the supporting documentation. We have had a few updates, I think, to the ASN.1 code itself. But we do have a few more commits that I actually have to update currently. So it is needing to be updated, and that's actually one of the things that are in the project side specifically to that. We are going to update the documentation first. Once we update that supporting documentation, we'll update the ASN.1 as well as the actual code as well as the TCIv3 document. Does anybody have anything else? Does anybody else have anything to add? Sorry, guys.
Okay. Next question. You only mentioned BSM and WSA. Can TCI version 3 be used to test reception of other messages such as MAP, SPAT, TIM, RSM? If not yet, any plan? Thank you.
Yeah, so in the TCI common types, there's actually BSM, WSA, MAP, SPAT, and TIM, I believe. Mustafa, would anybody else like to?
Yeah, that's correct. That is correct. You can specify the reception of the message. Yeah.
And with that scalability, I mean, we do have the ability to add other message types in whenever those come along.
Correct. Yes.
Okay. Next question. Hi, what does congestion mitigation under J3161.1 relate to?
Abhishek, I know that was in the TCI message generator, or TCI, yeah, the TCI application you guys created. Do you want to take that one?
It's basically to test, I guess, congestion when you know, there's a section in J2735 where the applications are supposed to react to a bunch of BSMs from different devices in a small area. So that is what congestion mitigation is. If the devices have are equipped to handle it, you can use TCI to, you know, enable, disable that functionality on the device, and then study the response of the device. So that is what congestion mitigation is. It's part of JSM 2735 SAE JSM 2735. So it's part of that. It's come from there.
Thanks, Abhishek.
Okay, perfect. And the last question is, should we consider shared XML configuration files? There could be many of them, so we could start with a subset of XML configuration files. Does that make sense, or should I read it over again? I'm not sure.
I think
Should we consider shared XML configuration files? It says there could be many of them, so we could start with a subset of XML configuration files. Seems to.
So I'm assuming the question's related towards the different the radio frequencies, I guess, for the V2X config. Bill, Mustafa, Dirk, do you guys want to go ahead and take that one?
Go ahead, Dirk.
I can start. Certainly, there's a reference XML configuration file that's been used for all the plugfests, at least, and that takes the definition that's out of J3161. I think it's a US specific 20 megahertz, whatever the safety channel is that's being used there. So yes, there will be different ones used throughout the world. From an OmniAir perspective, I guess the radio frequency parameter settings probably won't change that much. So multiples could be shared. One thing I could say is that I think we've shared, Aaron, with you before, a tool from Keysight that allows you to take those XML files and actually manipulate them and change some of the key parameters. So that's a free tool. It's maybe something we could consider putting on the GitHub as well, to actually modify them, download them to the devices, etc. Look at the impact.
That would be good. Yeah.
I wanted also to mention that, I mean, when we are talking about the XML file, then we are usually talking about one chipset provider, but there are also other chipset providers. So if we do provide different V2X XML files with different radio configurations included, it might be also a good idea to provide the radio configuration itself instead of the V2X XML files to be kind of independent, or at least in addition to the V2X XML file, so that everyone knows exactly, not only from the name of the V2X XML file what it's included, but also having already a clear overview about the radio configuration itself.
Yep, that XML file typically contains the 3GPP defined ASM1 encoded, UPR encoded RRC message. So that can readily be lifted from the XML natively. But you're right, Dirk, that is kind of specific to one chipset. I have seen other chipsets that certainly use the 3GPP standard defined part of that, but not necessarily the geolocation triangles, etc. are also in there. Yep.
No, I agree. I think, yeah, I think just like TCI, we're all striving for a standardized control interface. A standardized configuration files would be, I guess, the next level of just making everything a lot simpler in this industry. That's, I guess, a question to the chipset. I don't know, online. Yeah.
Okay, guys. Well, I just wanted to thank all the panelists again for their participation. Thanks, guys. Thanks, everybody, for attending. I think, Burkinda, you have a slide on PlugFest. Do you want to take that?
I can go ahead and take that. We have PlugFest coming up. Please join us in Ann Arbor, Michigan. We'll be there May 23rd through the 27th. If you guys are ready to make your purchase and register today, there is a $1,000 discount for the early bird registration, and we hope to see you there. Thank you again so much for joining us today. We appreciate you.
Thank you.
Thanks, Burkinda. Thanks, gentlemen.